want day 3 notes. You want day 3 notes. You want day 3 craft.
You don't get no pictures?
No.
This one?
Oh yeah, no, we're gonna use that. Yes, you're gonna need a way to access Desmos. Okay. So first thing we're gonna do, let's go ahead and read the question. You are attempting to retrieve an item from a shipwreck. So think about it. If you're retrieving an item from a shipwreck, you're gonna have to go underwater, right?
Yeah.
Okay.
Probably.
So the item is 120 feet below the surface. You don't have your scuba gear. So the equation here is going to tell us how far you can actually dive without your scuba gear. Okay, because we don't really know how deep you can dive. We need to see, are you going to be able to retrieve that item that's 120 feet below the surface? Okay, so go ahead and go to Desmos, and we're going to put in our equation. We're going to put our equation in.
Computer ain't done. I don't need my computer like 3 weeks. Do you have an X-Wing platform?
Okay, you're going to have to scroll out on this one. It looks a little, there's a lot going on.
Wait, my computer's not working. My bookmark is not
Okay,
working.
if you have to watch, that's okay.
My bookmark is not even finding it on the phone. Wait, turn this on. It doesn't turn on.
Okay, any issues getting that equation to show, excuse me, show up? Any issues?
Yeah, oh my god. My computer won't turn on.
I'm sorry, I don't know if I can help that. Maybe it's dead.
Mine says that, and it's not
Okay.
even because my office says 100%.
So, we need to see how far you dove. Where are we going to look to see how far, looks like the farthest
In the
point?
down,
What's that called?
the vertex.
The vertex.
Sweet.
Okay, which is 40 common negative feet. So let's think about what does X represent here and what does Y represent? X represents what?
Time.
Time. Okay, so it took you 40 seconds to dive
80 feet.
80 feet.
80 feet.
So if you can dive 80 feet, can you get the item that's 120 feet below the surface?
No. Because that means you gotta go home. 100.
Okay, so this is going to be no.
40 more.
Okay, because you can only dive 80 feet without gear. Okay, now if you had your scuba gear, you probably could dive that far. But without that gear, you can only dive 80 feet.
Have you ever been scuba diving?
Yes, I have.
Is it fun?
Yeah,
Is it hard diving?
it's not hard. I've never been skydiving.
I want to go skydiving.
As soon as I turn, you have to be 16.
Okay, we're not gonna get this done if we keep talking. I know we got 30-minute periods. We gotta rush today. Okay. How long do you hold your breath underwater? What do you think? What are we gonna look for that answer?
7 minutes. Oh,
How long? Is it 40 seconds?
No. No, it's not 40 seconds.
It takes you 40 seconds to get to the bottom,
Yeah,
right?
but-
Or well, to get to your lowest point.
Without
It takes you more time to come back up, so it actually takes you
80
80
seconds to not
seconds.
fall.
So you're not breathing right from 0 to 80 seconds. So it would be 80 seconds.
That's a whole minute and 20 seconds. I would not be able to not breathe.
Okay, so here we're going to add in the rate of change idea. Okay, so it says next I'm going to ask you about your average rate of change. Remember, this is the slope. Okay, I gave you the slope formula right there. In this problem, what does our y variable measure again? Yep, that's our depth. And that's in feet. Okay, the depth is in feet. And what about our x variable? That is time in seconds. Okay, so if we find a rate of change, it's going to be what per what? Feet per second. Feet per second. Think y over x. That's why we have feet on top, seconds on the bottom. Because it's y over our x value. What's that? Okay, I don't know. Did you have to get a new one? There's something here. Okay, part C. What is the rate of change? What is the rate of change of your dive from 10 seconds to 18 seconds? Now, I want you to think about, Okay, what values are they giving you? Are they giving you X or are they giving you Y values?
They're giving us both X and a Y.
Okay, are they as 1 second to 1
X is.
Why is it X? How do you know?
Seconds.
It's time, right?
Yeah.
So they're giving you 2 X values. How do you think we can find the Y value?
Go to the decimal graph.
Okay, so I'm going to show you. There's a couple different ways to do this. You ready?
Yep.
Okay. You can go like this, along it, and you can wait until you get to 10.
That's easiest.
Okay, 10, negative 35. Daniel, I want you to think of another way to find this. Yeah, right? We can use a table. So we go here, add our table. Okay, we can go down here, put in 10, enter, put in 18. There's our coordinate point.
Negative 58.
Yep, so it's 10, negative 35, 18, comma, negative 55.8. All right. Okay, how do we find the rate of change?
Do y2 minus y1.
Yep, y2 minus y1 over x2 minus x1. So here's our y2, here's our y1. So it's going to be negative 55.8 minus a negative 35.
So it's a plus.
Yes, that will be plus. Okay, then we do x2 minus, x1. So 18 minus 10. Okay, we're going to have to get our calculators out.
I got negative 20.8.
Oh, I thought it was 2.6. I could be wrong.
I could be wrong.
Oh, negative 28.8 on top, and then divide it by 8 on the bottom, yeah.
Negative 20.8.
Okay, you should get negative 2.6 feet per second. Does anybody confirm? Confirm? Gotta do what's right. You do get negative 20.8 on top, but you have to divide it by the 8 on the bottom. That should get you the negative 2.6.
Yeah, I was kind of just like, talking through it, and then you got the right answer, and I was like, wait, what? And then it was just the whole answer as a whole.
Yep, you were almost there. Okay, are we okay on that first part?
Yeah.
Okay, the second one, they also give you time. Hint, you ready for this? You need to listen. You need to listen to this. You will always be given the x. Okay, so you're going to get x. You're going to find y. You hear me when I say that?
Yeah.
Make your life a little bit easier. Okay, so go ahead and see if you can find the y values, which it should be pretty easy if you're on Desmos, because you can just put them into your table, 62 and 75.
Wait, I know where you can see those in my right. You got what?
Okay, they're up there if you need them. 62 corresponds to negative 55.8. 75 corresponds to negative 18.75.
It's like a trick.
No, it's not a trick. Why would it be a trick?
Because the numbers are like the same kind of.
They're similar. I'm getting 2.85 feet per second on this one. Okay, I want you to check it, make sure you can confirm that. Don't just trust me. Okay, because I want you to know how to put it in your calculator. Anybody else confirm 2.85? Okay. Now, part E. It says, on which interval are you moving the fastest?
The 62.
Where are you moving the fastest?
When the rate of change is 62 to 75.
62 to 75. Why?
Because it's 2.85, the other one is 2.6.
Okay, does it have anything to do with the negative sign or a positive sign?
No.
No, it doesn't, right? If you're going down versus going up, right?
Still moving fast.
Right. It doesn't change the steepness. So steepness, or the bigger number, is what you care about when it comes to where you're moving the fastest or the slowest. Does that make sense?
Yeah.
So negative versus positive, that doesn't matter when it comes to steepness or fast, slow. Okay. All right, any other questions on number 1? I know that was kind of a long one. Okay, number 2, we already have the picture on number 2. Okay, so we're going to go ahead and just look at the picture together on number 2. It says the depth of a river changes after a heavy rainstorm, which it should, right? It should go up if there's a rainstorm. Its depth in feet is modeled as a function of time in hours. Consider the graph. What is the average rate of change for the depth of the river measured in feet per hour between hour 9 and hour 18? What values did they give you?
9 and 18.
X. Okay. What y corresponds to an x value of 9? 18. Okay. What about our y value for 18? 21. Okay. Now this is where our section's at that we're looking at. Okay. Because keep in mind, if we're talking about a rate of change, is the rate of change going to be constant for that full graph? Why not? A rate of change is only constant when we have what kind of line? Completely straight line. That's when it's constant. Any other time, it's not going to be constant. So we're only talking about from 9 to 18 on our x-axis. Is this going to be a positive or a negative rate of change? Why do you think it's positive? It's going up from left to right. Okay, so when we get our final answer, it should be a positive value. Yeah, it can be. Okay, you should have 21 minus 18. 1/3. 3 over 9, 1/3. Okay, but this does matter, right? So it's 1 what? Okay, y values. What's y?
Oh, feet.
Yep. 1 foot per hour. Okay, so let's put it in context. The river, is it a river? Yeah. The depth of the river is increasing. How do I know it's increasing? It's a positive slope, right? It's increasing by 1 foot every 3 hours. Does that make sense? Okay, make a little note of that. I should say the depth.
I don't remember where I'm going for my next period.
We're going through period 8.
No.
Period 9.
Yeah. I don't remember if today is the day I'm supposed to go to the library or not.
Who do you have?
Oh, yeah, you have to go to the library.
All right. On to the next page, number 3. This is our last question together. Okay, this one's a little bit long too, but we're going to fly through it here. All right, a child is standing on a deck and tosses his toy into the air. Okay, so imagine them standing on a deck, they toss the toy into the air. Now, if they're standing on a deck, is that usually higher or lower than the water? Higher. Okay. So would we assume that they're going to start up in the air a little bit? They're not going to start at 0, 0 on the coordinate plane, right?
Yeah.
So they're going to start a little bit higher. Okay. So it says how high was the toy from the ground when it was thrown? We need to, well, or how tall is that?
Well, the deck plus 10.
Okay. So if we look at our graph, let's put our graph in here. Or let's put our equation in here.
Don't forget to add the 2. Oh, never mind. There's no exponent. Gabby, be quiet. How long did it take? How long?
Okay, so let's take a look here at what we have. See how it starts at a different place on the y-axis other than 0, 0? That is the height from where the toy is thrown. Okay, so it's 4 feet. So in this case, it would be 4 feet. Okay. How high is the toy after 1 second? Okay, how do we find this? Hello?
It is like communicating with you today.
No, it's not. Okay, how do we find where the height after 1 second? So I can do this, right? I can go all the way. Or I can just add my table in. Okay, it's already in there for me. 1 after 1 second, it's 9 feet in the air.
That's already high.
The maximum height is the vertex maybe.
Okay? What is the toy's maximum height? So if we think about maximum height, what point are we looking for? The vertex. Okay? Which value of the vertex? 10.125. Okay, this is the height. What is our x value?
1 minute and 75 seconds.
That's seconds. Okay? 1.75 seconds.
Oh, not minutes?
Yeah, that is not a minute.
It's 10.125. So if it was like 60 seconds, that would hit a minute. But not the 1.7. Okay, so 10.125. Oops. How long is the toy in the air? What are we looking for on that one? The x what? Yes, where it hits the ground. Oops, there it is. 4 commas here, so that would be 4 seconds. It takes 4 seconds for it to land.
It's gonna take longer than that.
Wait, is it gonna land on the ground or back on the deck?
Or in the water.
Or is it gonna land on the
Probably gonna land in the water. I would assume he's like standing on a deck. I mean, maybe he's not standing on the edge of the deck. If you stand on the edge of the deck, it would go in the water. Right, it would go
They're
in the
both
water.
going to the water.
All right, part E. At 0.5 seconds, the toy was 7 feet in the air. That's a coordinate point. 0.5, comma 7.
Where did the water come from?
What? The lake.
Wait, why are we all talking about water? Where is it from?
Because it's on a deck. It might not even be water. It might just be standing on a deck. It can be. It doesn't always have to be by water.
They'd be like, go to the back deck and get the sprinklers.
Okay, after 1.5
Nobody ever said that to me. Because you don't have a back deck.
after 1.5 seconds, the toy was 10 feet in the air. So that's our other coordinate point. Now we're going to find the rate of change. How do we do that?
You do the minus 10, minus 7.
We
minus
do
1,
our
minus 4.
slope formula. y2 minus y1.
Why would you say that out loud?
It's 3.
Okay, you should end up with 3 over 1. 3 what?
3 babies. Over 3 seconds.
Over 1 second.
Okay, so that means when he throws it, right? This is when he throws it. This is when it's going up. Okay, it's traveling at 3 feet per second. That's the rate. Okay, now let's look at when the toy is going. I think this is down. Yeah, this should be down. 2.5, comma 9, and 3, comma 7. Okay, I'm going to have you do that one on your own.
I can't believe that it's like, I woke up literally and I was like, oh, look at the TV and it says open. And then I went to my room and my phone buzzed and it said some 2 hours away and I was like, yes. But I was already up at 2 o'clock in the morning, so I didn't really know.
What did you just say?
I woke up at 3 o'clock in the morning.
Okay, we should get -4. We get -4?
Yes.
Okay, so the first one is where it's going up 3 feet per second, then it's falling at 4 feet per second.
Negative?
Altogether, it's negative. Oh. That's down.
Okay, compare the answers. What's your answer?
Okay, how do I tell the difference between something going up and something going down?
The negative?
Right, it should have a negative slope or rate of change like it does in part F if it's going down, positive like in part E if it's going up. Which one's going faster? Which interval?
The first one.
Yep, the second one, from 2.5 to 3. Has nothing to do with positive or negative.
Works with gravity.
Yep. It works with gravity, but also we want the biggest number.
Sometimes gravity doesn't like us.
The 3 questions below the last one that we just did is the practice. That's all it is for today. Okay, just 3 quick questions. Kind of worked out nice for a 2-hour delay day. Okay, You were out of here at 1:56. So you have like 8 minutes. Okay, while you get started on that, okay, I want to talk really